I welcome you all to the short video lecture on corrosion and its prevention. Today's session we will be seeing about the introduction of corrosion, facts about corrosion and causes and types of corrosion. So first let's see the definition of corrosion. What is corrosion? Corrosion is the destruction of the material due to unwanted or unintentional chemical or electrochemical reactions with the environment. It is an unwanted reaction. It may be chemical or electrochemical in nature. What are the different examples of corrosion? The most common example of corrosion is rusting of iron. This is a very familiar phenomenon. Next is blackening of silver articles, that is due to formation of silver oxide. Then formation of green film on a thin film of green color will be formed in the copper articles, that is due to copper carbonate when it is formed due to the presence of moist carbon dioxide in the environment. Now there are many major accidents that happen due to corrosion. Some of the examples are global tragedy. Global tragedy in 1984, that was due to the leakage of a deadly poison known as methyl isocyanate. Then that happened due to the leakage in the pipeline that was having leakage in the pipeline in which methyl isocyanate was stored. And another example of an accident that happened due to corrosion is the Titanic ship accident due to presence of dissimilar metals involved in the hull and the rivet. Okay. And the third example is the swimming pool roof collapse in Switzerland in the year 1985. Now facts about corrosion. What is corrosion? Corrosion is an oxidation process. It's an electrochemical process and it's a natural phenomena. Corrosion is a natural phenomena and it has tremendous economic loss. It leads to tremendous economic loss. Moreover, corrosion is just a reverse process of extraction of metal. I will explain how. Next we will see the causes of corrosion. What leads to corrosion or the reasons of corrosion? We know that most metals other than noble metals such as gold, silver and platinum, all other metals are found in nature in the combined form as their sulfides, as their oxides, as their carbonates. Okay. So, in the nature, metals are found as ores, metal ores in the combined state. So, we apply energy and convert these ores into pure metals. And this process is called metallurgy, which involves lot of energy. So we do many processes like roasting, calcination, flotation, smelting, and we supply energy and convert these ores which are in the combined state and form the pure metals. So when in the state of ores, the metals are in highly stable state. This is a highly stable state. And pure metals are in a less stable state. So what happens when they are in a highly unstable state? Naturally they have the tendency to go back to the combined state. So the reverting back process is nothing but our corrosion. So metals tend to undergo corrosion because they are in a thermodynamically unstable state. When they are pure, they are in a thermodynamically unstable state. So they have the tendency to go back to the combined state. This is the reason for corrosion. Next we will see the different types of corrosion. What are the different types of corrosion? There are two types of corrosion: dry corrosion or chemical corrosion, wet corrosion or electrochemical corrosion. Dry corrosion is called chemical corrosion and wet corrosion is also called electrochemical corrosion. We will see dry corrosion in detail. Dry corrosion occurs when there is a direct attack of surrounding gases, atmospheric gases, direct attack of atmospheric gases such as oxygen, hydrogen sulfide, nitrogen, halogens, carbon dioxide. So all these atmospheric gases, other gases present in the atmosphere directly react with the metal surface, and this leads to dry corrosion, otherwise known as chemical corrosion. So there are three different types of dry corrosion. First type is attack due to oxygen. Attack due to oxygen. Okay. Now consider a metal surface. We have a metal surface, and this part is exposed to air. Okay. We have oxygen here all over, surrounded by oxygen, and the top surface, the top layer of metal surface is exposed to oxygen. So the following reaction will take place. Metal will become metal is losing electron and it is forming metal ion. Now this metal ion, oxygen present in the atmosphere will take up this electron and will form oxide and it is forming oxide ion. Now this metal ion and oxide ion will combine together to form metal oxide layer. This is metal oxide, this is the metal ion, and this is oxide ion. These two combine together to form the metal oxide layer. So the initial step in the attack due to oxygen is formation of metal oxide layer. First step is formation of metal oxide layer. Formation of metal oxide layer. After that, what happens? Now, depending upon the nature of the metal oxide layer that is formed, further corrosion may take place or corrosion may stop at the first stage itself. So, depending upon the nature of the metal oxide layer that is formed, the thin layer of metal oxide that is formed, depending upon the nature of the metal oxide, corrosion may take place. Further corrosion may take place or corrosion can stop in the first stage itself. So, certain metals like alkali metals, lithium, sodium, potassium, alkaline earth metals like beryllium, magnesium, calcium, strontium, such metals, they can react with oxygen at low temperature itself. They will react with oxygen at lower temperature. Other metals can react only at high temperature, whereas the noble metals will not have any reaction. Now, the nature of the metal oxide layer can be of 4 different types. Suppose the metal oxide layer that is formed is stable in nature. Suppose it is very stable, metal oxide is very stable. That means it is non-porous. It does not have any minute pores. It is tightly adhering. It is tightly binded to the metal surface, tightly adhering. Metal oxide layer is non-porous, it is tightly adhering, then it is protective in nature. That means it will protect the metal from further corrosion. So which type of metals will undergo this, will form the stable metal oxides? Stable metal oxides are formed by metals like aluminium, tin, lead, copper. So these metals will form a very stable metal oxide layer. Next, suppose the metal oxide that is formed is unstable. If it is highly unstable, what will happen? If the metal oxide is unstable, then it may lead to metal oxide is unstable, then again it will form the metal ion and the oxide ion. So it's a reversible process. So such metals will not corrode at all. Corrosion will not take place at all. Once the metal oxide layer is formed, again it will go back to the original state. So metal oxide formation is unstable. Metal oxide that is formed is unstable, so corrosion is not taking place at all. That is the second type. Suppose the metal oxide that is formed is volatile in nature. What will happen? What do you think will happen if it is very volatile? The metal oxide is volatile. That means the rate of corrosion will be very high. Metal oxide is volatile. This is the third type. Volatile nature. It is volatile in nature. For example, our molybdenum oxide. Molybdenum oxide that is formed is very volatile in nature. So, every time a layer is formed, it will vaporize and go off, and a fresh layer will be available for oxygen to attack. So, the rate of corrosion will be very high in the case of volatile metal oxide layer. And the fourth type, if the metal oxide that is formed is porous. If a porous metal oxide is formed, what will happen? If the metal oxide layer that is formed is highly porous, then that means it is non-protective in nature. That means it will lead to further corrosion. Further corrosion will take place. Oxygen can easily penetrate inside and attack the surface. It can go inside the metal, can seep inside the metal, and it can attack the metal atoms present inside, deep inside. It can cross the barrier of the initial metal oxide layer, and it can attack the metal ion. So, if the metal oxides are porous in nature, then it means it is non-protective. So, these are the four different types of metal oxide layers. If the metal oxide is stable, then it is non-porous and it is protective in nature. Metals like aluminium, tin, lead and copper will form a stable metal oxide, and corrosion will not take place. Corrosion will stop with the first step itself. First stage. After the first stage, further corrosion will not take place. If the metal oxide is unstable, such as the case of noble metals, gold, silver, platinum, metal oxide is unstable, so corrosion will not take place at all. Then in the third case, if it is highly volatile in nature, for example, in the case of molybdenum oxide, corrosion will be accelerated. Corrosion will take place very quickly, and the whole metal will be eaten off. And suppose the metal oxide layer is porous in nature, as in the case of our lithium, sodium, magnesium, such metals, which forms a porous metal oxide, then it is non-protective in nature, so corrosion will take place. Now, there is an important rule called the Bedwet rule. This rule predicts whether the formed metal oxide is protective or non-protective. According to the Bedwet rule, if the volume of the metal oxide that is formed is less than the volume of the metal consumed, then the metal oxide is non-protective. If the volume of metal oxide is less than the volume of metal consumed, then it means the metal oxide is non-protective or porous. So that's all with respect to oxidation due to corrosion due to oxygen attack on metals. Next we will see corrosion due to hydrogen. What happens environment in which metal is at a high temperature. This may lead to two types of reactions. One is called hydrogen embrittlement. So what is hydrogen embrittlement? Corrosion due to hydrogen. Corrosion due to hydrogen. When hydrogen is present in the environment, it leads to hydrogen embrittlement. Hydrogen embrittlement. Suppose iron is there in an industry, it's at a very high temperature. This iron, when it reacts with hydrogen sulfide present in the environment, it leads to the formation of iron sulfide, and in this reaction hydrogen gas is liberated. This liberated hydrogen will get trapped in the minute cracks, and it will lead to it will increase the pressure in the gaps, and it will lead to explosion. So that it will lead to weakening of the material, and finally it will lead to explosion. So this is called hydrogen embrittlement. There is another process called decarburization. Decarburization. We know that in steel we are adding carbon. We are adding carbon to increase the strength of steel. Okay. In steel, we are adding carbon to increase the strength of steel. So when hydrogen is present in the environment and steel is at a very high temperature, then what happens? This carbon present in the steel will react with hydrogen, and it will form methane gas. And the methane gas will go and trap in the voids or small minute hair cracks of the material, and it will lead to decrease in the percentage or amount of carbon present in steel. So automatically what will happen? This will lead to decrease in the mechanical strength of the material. So this process in which the percentage of carbon present in steel is decreasing due to attack by hydrogen is called decarburization. This process is called decarburization. There is the next type of, one more type of corrosion, dry corrosion, that is called liquid metal corrosion. So what is this liquid metal corrosion? So liquid metal corrosion is nothing but when we have a liquid metal moving over a solid metal. Liquid metal at high temperature, when we have a liquid metal at a high temperature, flowing over a solid metal, So it may lead to two situations. In one situation, either the liquid metal may dissolve. It may dissolve the solid metal. Liquid metal may dissolve the solid metal, or the other probability is the liquid metal may penetrate inside the solid metal, and in both cases it will lead to weakening of the material. And this type of corrosion usually is common in nuclear reactors. That is liquid metal corrosion, liquid metal flowing on a solid metal at high temperature. So these are the different types of dry corrosion. So small recap, dry corrosion is also called chemical corrosion. Dry corrosion can take place due to the direct attack of certain gases present in the atmosphere, such as oxygen, hydrogen sulfide, chlorine, hydrogen, nitrogen. All these gases, carbon dioxide, such gases present in the environment may directly attack the metal, and this leads to chemical corrosion. And the first of the type is a direct attack of oxygen on the metal. So in the first step of direct attack of oxygen on metal, the first step is formation of a metal oxide layer. Then depending upon the nature of the metal oxide layer that is formed, further corrosion can take place or corrosion can stop in the initial stage itself. Now the metal oxide layer that is formed can be of 4 types. If it is stable, then it is protect. If it is stable, that means it will not lead to further corrosion. Then it is protective in nature. It is non-porous. If it is stable, it is non-porous. It is tightly adhering, then it is protective in nature. Metals like copper, tin, lead and aluminium will form such stable metal oxide layers. If it is unstable, then corrosion is not going to occur at all. The third type is volatile metal oxide. Volatile metal oxide in the case of molybdenum oxides. Fourth type is very unstable. Fourth type is porous. If the metal oxide that is formed is porous in nature, then it will lead to corrosion, aggravated corrosion. Corrosion will take place. Then next is corrosion due to hydrogen. When hydrogen is present, there are 2 probabilities. Either when hydrogen is present in the atmosphere may attack the metal and it may go and deposit in the small voids of the material and it will build up pressure and it may lead to explosion. That is called hydrogen embrittlement. And the other probability is decarbonization. When steel is present at high temperature and there is hydrogen in the environment, this hydrogen will react with the carbon present in the steel and it will form methane gas. This methane gas, once the methane gas is formed, the proportion of carbon present in the steel is going to decrease and this will lead to weakening of the material. And the third type of dry corrosion is the liquid metal corrosion. In that case, liquid metal which is at a very high temperature, when it is flowing over a solid metal, what will happen? It may lead to either the solid metal will dissolve in the liquid metal or the liquid metal will penetrate inside the solid metal. So these are the chances. So that's all about dry corrosion. With this we end this lecture. Thank you.